Hello everyone. So in this video, we will learn about how to query data from existing databases and what kinds of queries you can write, what levels of queries you can write, and how to actually use them in your day-to-day life when you're extracting data for a report or for some insights that you want to share. In the previous video, we understood about theoretical knowledge around databases and SQL. Be sure to check it out in case you haven't already. And without any further ado, let's start. So, when we talk about SQL, the very first thing and the most important thing is understanding how these SQL queries run. Now, what most of the people don't understand is how these queries are executed in the system. I'll show you how a normal SQL query looks like from a statement basis. So you normally start with a select statement, then you have a from statement, then you join, then you have a where statement, then you have having, group by, order by, and limit. Now, while your SQL query looks like this, it's not necessarily interpreted by the system in the same manner. For example, from is the first element which gets picked up. Why? Because from tells the system or the database where you want, actually not where, which table you want the data from, right? Then join comes in. This join statement tells you which tables to join with the base table that you mentioned in the from statement. So this is an extension of from, but it helps the system understand that okay, what all tables need to be considered while getting the query that you requested for. This is the third option or the third statement, which tells you where to filter or what to filter from, right? So for example, you might have a data set in your tables which is telling you, let's say, customer data. Now within this customer data you might have a lot of ages, right? So every customer has their own age. Now you want only customers which are over 20 years old, so you can just write where age is greater than 20, and that way you can actually query the data. Then comes select. Now the select statement tells the system which all columns or if any aggregations are required on the dataset that you want. So this is the main part where you actually define what structure you want the data in and what all columns you want to see, and if there are any logics you want with these columns. Then comes the having. So let's say in your select statement, you have some aggregations and you also want to put some filters over those aggregations. So those aggregations can be filtered out through the having clause. The basic difference between where and having is thus this, that the where clause can be used for filtering an unaggregated data, but having filters out the aggregated data only. Once you have defined your select statement and your having statement if required, the group by tells the system that okay, let's say you have put a sum, that you need a sum of all the orders in your system by a customer ID. So you can actually say group by customer ID so that all the orders for a single customer are grouped together and then a sum is given. If you do not put this group by, what will happen is that it will give you a sum of all the orders in the system and you will get an incorrect data. So this is a very important statement. Order by is the seventh in the number. Order by tells the system in what ordering do you want your data set to appear. So let's say you want your data set to be in the descending order of the total sum of the order, right? So you can do a descending order there. Then limit is the last one, which tells the system how many rows do you want to see at once. That's about it. Nothing too complicated about limit. So this is how the order of execution is for an SQL statement. Now that we have understood the order of execution, we will move on to some practical examples. So before we start off with actually writing the queries, I would like to show you the data which I've already imported. Just to save time, I did not go through the process of importing data in this video. But going forward, I will put up a video on how to ingest data into a Postgres database or any other database so that you can practice yourself. For this video, the data set that I have used, I will attach a link in the description so that you can download it from there. Coming back to this, so we can understand the statements later, but I'll just show you the data set that we have. So we have two tables, which is one is a customers table. And if you query this, you will see, so we have around 1,000 customers in our database. If you see, it keeps loading and we have 1,000 rows. So these 1,000 rows are individual or unique customers within our database. The second table we have is orders. And if you see that we have a lot of orders as well. I think we have around 3000 orders in this, and they are randomly aligned to each customer ID. If you see, there's a customer ID column. So this customer ID column is actually the foreign key which is attached to your customers table. If you see here, if I hover here, it will tell you column customer ID refers to the public.customers. Public is a schema and customers is the table name. Okay. Now that we have an idea of the data set of what we are going to use, we are now going to dive into some SQL queries. So we will first start with level 1 of SQL queries, which is the beginners level. And in this level, we will cover select and where statements, and we will only look at the basics of it. So the very first thing that we will actually see is how to get all orders in a database. And this is the same query which I did to show you the kind of data we have. So this is going to be simple select star from orders, and I just executed by pressing command and enter, control and enter if you're on Windows. Now, if you see from the order of execution that we saw before, so the from statement tells the database that I want the data from the orders table. This is the name of my table, and I want the because I have written star. Star means all the columns. I do not want to specify which columns I want. I just want all the columns. Let's say I want just the order ID, right? So I can just write order ID, and it will give me all the order IDs. If I want the customer ID along with it, I can just write another thing, and it will give me. And if you want all the columns again, you can just write star, and it will give it to you. What you can also do is if you want order ID and then all the columns, so you can just do this, and this will give you order ID twice. You may not want to do it every time, but there are use cases to it, so you can. We will see that later. I'll fix this for now. The second one that we will look at is getting all customers, which is also the similar thing as orders. We will just do from customers, and it will give us all the customer IDs or all the customer data that we have. Moving on, we'll see get all orders on or after a certain date. In this case, we will take 1st of July 2021. So the data set that I've picked up is actually for 2021, the year 2021. So we do not have data beyond that. We do not have data before it. So this for this example, I've taken a date of 1st of July. So for example, you want data for a different date. We can use a different date as well. For this example, specifically, I'm using 1st of July. Now the question says that I want all the orders on or after 1st of July, which means greater than or equal to. This is where the where clause comes in, where we want to filter the records. So you write from orders. This is the same as the what we have written here, but now we will add a where clause, which will say, now if you see there's a column called order date, right? So this is what we want to filter on. So we'll write order date greater than or equal to. We'll open quotes and we'll write 2021 0701, and here you go. So now all the orders which you get are over and above 1st July 2021. If you see any date you pick up here, if I just sort it by ascending order, you'll see the first date is 1st of July and the last date is wherever the data we have. So it's 30th of December. So this tells us that our work query is working fine. Moving on. So the next thing we can look at is get all delivered orders. Now you may want a scenario where you only want to get data which is already delivered and maybe for some analysis. And similarly, we will use the where clause here and selects from orders where order date. Sorry, not order date here. We'll need the status. Right? So there's a column called status. If I scroll, there's an order status, right? So we'll use order underscore status is equal to delivered. And if I run this, I will get all the orders which are delivered. If you see this column, this is entirely delivered. We will not have any other orders here. Now, what if you want a combination of all the orders delivered after 1st July 2021? What we can simply do is all orders after 1st July 2021, all delivered orders. Now I'll do this same. Now we already have a order status of delivered, and so and is another keyword which we can use. So and or is are two keywords which we can use. So because our question said that we needed all orders delivered after 1st July 2021, so we'll use and. because we want both the statements to qualify. If we want either of the statements to qualify, we could have used or, which we'll look at another in the next question. So now we will add order date is greater than or equal to the same as above, right? So 2021-07-01. And if we run this, we'll get all the orders which were delivered after 1st of July 2021. Next, we'll see all orders which are either delivered or were placed on or after, let's pick a different date this time, 1st of August 2021. For this, we will do the same thing again with one minor change, which is changing and to or, and order date will now be 0801. Now, if you see, we will get all the orders which were either delivered. So, if you see, this is pending, but why did it come into our results? Because it was after August. So, we'll get all the kinds of orders which qualify either of these statements. The next thing we will look at is a very small example of concatenation, right? What happens in concatenation is that let's say that there are two columns in a data set that you want to check, that you want to concatenate together, that you want to join them together, and you want to show them as a single column. So you can use the concat method for it. Now, in the customers table, we have the first name and the last name, and we want to show them as a full name. For that, what we can do is show full name of customers, select star from customers, and now because we don't want the entire list of columns, we will remove the star and we will use the id, which is the customer id in this case, and we will do a concat. We will mention the first set that we want to concat, the first column. Then we, to add a space, we can just open a quote and we add a space here and comma the last name as full name. What as does is this as will add an alias to your column. So if for a normal column, let's say ID, I want to display it as the customer ID. I can just write customer ID as customer ID, and it will show as customer ID instead of ID. So in this case, I did not want to show it as a concat written there. If I remove this and I run this, you will get concat. But I want to show it as a proper column name. So I will write as full name. And if you see, this will change the column name that we get the output in. And if you also see, the first name and the last name has been concatenated for all the customers. If the last name is blank for some customers, it will just show that as null, or it will not show it when you have concatenated it. I'm not sure if there is an example of that right now, but if there are scenarios where one column is empty, then it will not show anything for it, right? So now we will look at level 2 of queries, which is medium level. In this one, we will cover joins, aggregations, group by, count, sum, order by, and that's it. Now, to explain the concept to you, I will first write a query. I will just copy it from here so that I want to show you something, and then I will explain this query in a later stage as well. So this query will give me all the customer IDs and the order count with it. So if you see, this customer ID 10 has 0 orders, but if you keep scrolling down, the number of the number of orders increase. It's 1, 2, 3. So these customers have done 5 orders. Now, these customers which have done 0 orders, I will just note them down here. Let's just note down two IDs, 10 and 211. I'll just write it here, no orders. Right? Okay. The first concept which we will see here is joins. Joins is a very important concept from an analytical point of view as well, and from a logical point of view as well, because you want to understand, or if you want to get the right set of data, it's very important that you don't mess up your joins. There are 4 kinds of joins. One is a left join, right join, inner join, and a full outer join. We will understand it through a Venn diagram. So let's say this is your one circle, this is your second circle, and this is your table A, this is your table B. Now, a left join is this. Anything to the left and which is not intersecting is your left join. Right join is similar to left, where only the right part of your Venn diagram is located. This is right, this is left. Your inner join is basically this. So this portion is your inner join, and a full outer join is basically everything in this Venn diagram. The unmatched plus the matched columns is a full outer join. This is how you can actually understand this. Moving on to practicing some queries for left join. Now let's consider that you have a requirement from your stakeholders where you want to send them the data for all the orders along with their customer details. So how you can do that is you write select. For now, we'll use star from orders. Now, because we are joining two tables, we need to give them aliases. So you can just, without writing as, you can, while in the join or the from statements, you can just write space and I will write O here, which will give my orders table an alias O. So that's easier to reference it later. Then I will do a left join of customers. I'll give it an alias of C on. The on statement tells you that if I'm joining the table, on which column do I use a reference for joining the table. So in this case, we have the customer ID on which we will do the join. So C.id is equal to O.customer ID. Please understand the statement. On C.id is equal to O.customer ID tells the SQL statement that this table customers needs to join on orders using the customer ID column from the orders table and the ID column from the customers table. If I just simply run this query, you will see that first we get all the orders table, all the columns which are there in the orders table, and then we get all the columns which are there in the customer table. So if you see this customer ID and the ID column are actually the same. If you see here, it tells you that it's a primary key, it's a unique key, and here it tells you it refers to the public.customers table. So if you want, you can just say that, okay, I want all the orders data, but for the customers table, I only want their email ID. So I just write this, and if I press command enter, I will only get the email ID. This is how you can join two tables. As we saw in the Venn diagram, the left join is for all it takes into account all the data which is there in the left table, but the right join will take into account all the data that is there in the right table. Now from the previous example which we saw that 10 and 211 order customer IDs did not have any data. They did not have any orders. So how did they? So how will it appear in this data, right? Because the orders table is on the left, so it will not appear. These customer IDs will not appear in the data set in the resultant data set. We can actually check this, right? So you can say where c.id is equal to 10. If I do this, I get no results because there is no order corresponding to customer ID 10. If I make it 11, I will get some orders because the customer ID 11 made some orders. Similarly, for 211, I get no orders, but for 212, I get some orders. Now, let's say the requirement changes. You are asked to give all the customers' data along with giving all the orders with for each customer. But if there is no order for that customer, it's completely fine. You can just show a blank. So we will just copy that same statement. We will paste it here. You will change the left join to the right join. Or the other way of writing it is shifting customers to the from statement and orders to the right join state to the join statement and making it left. So that way the customers table then go on the left and the orders table go on the right. But we can actually just change the left from right as well. It works in the same way. Now if I run this query, I get a similar result, but the data is different. I'll tell you how. If I now write where c.id is equal to 10, you see it gave me all the columns as null for orders, but I have an email. What this tells me is that against all the customers where there's no order, it is giving me a null value. That is how it works. Now, if I write 211, it will still give me null. But if I write 212, it will give me how many rows, whatever the count of orders this customer has, that number of rows it will show up here with the email repeating. Now, if you want all the orders, let's say you would only want customers where we have some order, right? So we will just copy this statement, you will paste it and you will write inner. This will give me only customers which have an order. Now, technically in this case, the left join and inner join will return the same statement, but will return the same data. But this is very essential to note that in some cases or in some logics or in some tables, this may work differently. It all depends on what kind of data you have, what is the ask. So for our data set that we're using, we will get one and the same result because the orders for the customers which we have orders, we will definitely have some data in the customers table. But it is possible that we are comparing two tables where we do not have all the data sets. Now the full outer join. I will just copy this, paste it, full outer. Now, this will give me all the data. It will not care whether there is an order or not. It will not care whether there's a customer ID or not. Let's say in the orders table tomorrow, I add an order for a customer ID which does not exist. This will still give me that data. In our case, we do not have any inconsistencies in that sense, but you may be able to find inconsistencies this way. Or this is useful in other cases also. Now there's a fifth type of join, which I did not tell you initially, which is a cross join. Now, why I did not tell you is because it doesn't necessarily fit into the Venn diagram of it. But a cross join is actually a very helpful join in some cases. I'll just copy this and I'll paste it. And I'll change full outer to cross. And now if I run it, okay, there is an issue, which is, just a moment. Oh, sorry. So for the cross join, we do not need to write an on statement because cross joins do not work that way. If I just do this, now what cross joins does is that it will pick up each row of the base table and each row of the joining table and it will merge them. So for each row of the base table, we will have one record of the table that we're joining. So if you see for order number one, we have one customer, right? Actually, for this example, I'll change this to C star. Now for order number one, we have the customer ID, we have this ID one. For order number for now we will have all the 1,000 customers, but this order will remain the same. If you see, this customer ID is also not changing. So now what will happen is it will go through all 1,000 customers. As soon as the 1,000 customers are over, it will now pick up the second order and it will run all the customers again. Now this cross join will exponentially increase the size of the data set that you get in return. However, what happens is that this is a very useful trick in some questions, which we will see in future videos. These actually are very, very useful in some cases. I will try to cover it in this video. However, it was probably will go into the next one. So these were all the joins that we have. Now, what we will do is we will start with some other questions, which are some aggregation questions, which will all, and we will include these joins in the mix in some questions. Now, let's say you have a requirement of getting the total sales of the company till date. For this question, we will do select star from orders and you will remove the star, we'll write sum and total price as total sales. If I run this query, if I will get one number, which is the total sales of the company for all the orders that we have. The next thing which we'll see is we will see total sales grouped by a payment method. So let's say you want to see, or maybe the finance teams wants to see that which payment method got how many orders and what is the amount of it. So we'll write, just to start the statement, we'll do star, but we'll later change it from orders. Now what do you need? You need total sales grouped by a payment method. So first thing you need is the payment method. It automatically wrote this, but I'll just fix it. Comma. Now I need all these sales, right? I'll write sum. I'll do total price as total sales. Now we will use the group by here because we want to group all the sales to a particular payment method. Group by one. And let's say for this question, I also want to order them by column number 2, which is my sum, or I can also write it as total sales, and I want it in the descending order. So I write DESC. If I run this, you see I will get in the descending order of sales of the PayPal got the highest sales for this number, credit card had these sales for this number, cash on delivery were these number. This is how you actually group and order data. The next question we will see is the top 5 spenders for your company or for your business. This is also something that you might see in a lot of analytics questions because this is an important metric for people to track who are your top spenders. Maybe you want to give them more offers. Maybe you want to send them a gift or anything. Right? You could do a n number of things with customers who value you. So to do that, okay. So what we will do is we'll do a select star from orders. Now we will do left join two customers. We can use inner also, that's completely fine, we'll use inner or left, it's interchangeable. On c dot id is equal to o dot customer id. Now what is it that you want? You want the top 5 spenders which are your customers, so I will take, and I also want their full names. I will take the customer id. You can also take it from the customers table, either way it's fine. Now I want to have the full name, so I will use the concat which we saw above, which is first name and last name as full name. And we need, which is the main thing, right? You need a sum of total sales for each customer. This is actually total price. Total sales is the name, is the alias name. Now, again, we'll do a group by the customer ID as well as the full name, which doesn't matter in this case because it's the same thing, right? It's unique. So for each customer ID, we'll get this. And we'll also order it by 3, which is our total sales, and in the descending order. Now we will limit the records to 5. Why? Because we need the top 5 spenders. Now if we run this, we get all the IDs, all the 5 IDs which are spending the most on our platform. Let's say the question was reversed. Who were the least 5 spenders in your company? You change this descending to ascending, and you get that number as well. But in this case, we need descending, so here we are. Similarly, you might also be asked that please give me the top 5 average or average spenders, right? Average order value spenders. So the difference between total spend and average order value is, let's say you have 5 orders of 100 rupees each. So your average order value is 100 for that customer. But if I have one customer with just 500 rupees of order, then the average in that case goes up to 500. So these two metrics are incomplete without each other, but we will see how to join them later as well. So I need top 5 spenders by average order value and full names. Because we are doing the same thing and we're just changing one thing, we will copy and paste the statement. We'll change sum to average. AVG will give you the average. And total sales will change to average sales. Or we can change to order value, average order value. If I run this, I will get the top 5 spenders according to the average order values. And so if you see the customer IDs here, which were returned, is different from what we got here. And that's exactly why we need both the metrics together to understand the actual value that a customer is bringing to us. Now, similarly, you may need all the orders grouped by a particular order status. So we'll do, yeah, order status, right? So we have an order status column. From orders, we'll take up the order status column. This is a primary column. Now we need a count of all the order IDs as order count. We will group it by order status and we will run it. Now if you see, we got all the delivered orders, shipped orders and pending orders separately. Now we will move on to level 3. This is the advanced level of queries. And here we'll see subqueries, a little bit of ranking somewhere, window functions, etc. Now, let's say you want the latest order for each customer. You want the latest order ID for each customer. How do you do it? I want the latest order ID for each customer. This is what I need. Now, this is a subquery question. Now, how we will solve it is, first I will write 2 queries, then I will show you how to merge it, right? So our first step is to get the max of order ID for each customer. For this, we will do select star from orders. Now, this is a simple question because we saw similar questions here. We have to get the customer ID, and against it, we want the max of order ID as the latest order ID. If I run this statement, oh, I have to do the group by, right? You see, I got an error because our database understands that I have not grouped my data. If I group by it, now I see for each customer what is the order ID what is the latest order ID which they place an order for. So this is, now I've got this data of the latest order ID. Now I want the order details for it as well, right? Now I can't do this in the same statement, because if I try to add a star here, it will not work. It will show me an error because it wants that all the columns as well appear, all the columns for the star statement also appear in the group by clause. But that's not possible, because if we start grouping each and every order ID to customer ID, we will not get the correct data. We will get all the columns here, all the orders here, even if you've written max, because it will try to group one customer ID and the order ID together. So it will give you the max order ID of each of these groups. So that is not the correct way. Now to how to do this, right? This is where step two comes in. Why is it showing this? Oh, I have an extra comma here. Okay. Okay. Step two. What is the step two? Right? Step two is now we have to get the order details for the latest order for each customer. So right, get the order details for the latest order of each customer. This is where subquery comes in. We need all the order details, so we do select star from orders. Now we have to join this with the max order ID which we got from here. So we can just copy this statement. We can come here, we can paste it here. What this is doing is, when we do this, it considers whatever inside is in this of this parenthesis, the query inside this parenthesis, as another table. So the output of this statement will be considered as another table. So in a join, I can name it as latest. Now the table, sorry, the column names which I mentioned here will act as the column names for this latest table. So I want to join them on latest dot customer ID and latest dot, sorry, and order and o dot customer ID. Right. Now I've joined the latest customer ID and the order ID, and I will also join it. Oh, sorry, not and, here will be equal to, and I will also join the latest order ID with the order ID of the orders table. Now, if I do a select star on this statement, I will get all the orders which are the latest order for each customer. If you see, the number of orders which I get here is not actually 3000. It's actually 946. This is the end of rows. This is 946. But we actually have 3000 orders. So this is telling me that there are 946 customers who placed an order, unique. And for each customer, these are the latest orders that they have. There's an alternate way of doing this. What happens is that right now we used the order ID as our max and to identify the latest order. But what if your order ID is not stored in an integer format? Right now we were able to get max because it's an incrementing integer. But what if you have something else? What if you have an UUID? A UUID is an alphanumeric number. So maybe it looks like this dash, this dash, this. Whatever it looks like this. You will never know what is the latest UUID. There is no pattern to this UUID, right? In this case, what we will do is, let's consider that this is the case. What we can do here is that, so there's one more thing which is called as temp tables, which we can use by the with statement. So we can create a temp table using the with statement. How it works is, again, we'll first identify what data we want. So here, the data that I want, uh, actually let's do it the other way. We'll use the, just a minute. So we'll use the orders table here. And what do we need? All the columns, but we also need one identifier which tells us which number of order is this for this customer. Let's say I have 10 orders. So I also have a sequence of orders, right? I ordered one today, one tomorrow, one day after tomorrow. So it is possible that I have multiple orders. So for those 10 orders, what is the order, what is the rank of these orders, in a sense that which is the first order I did, which is the second order I did. To identify that, we'll use something called as row number. This is again a window function, and we'll use something called as partition by or and over, right? What this does is, I'll write over partition by, I'll explain what this does, by customer ID, and I want the ordering by order date in the descending order. This will become my customer order sequence. Now let me explain what this does. The over partition by tells me that I want the row numbers partitioned by each customer. So if I write a normal row number, it will give me a sequence. It will give me a serial number. But I want the serial number to reset for each customer ID. So let's say for one customer ID, I get all the sequence together. Then as soon as the second customer starts, the sequence resets. I'll show you how it works. If I run this query right now, if you see, these are the normal orders. If I go to the end, I have a customer order sequence. You see 1, 2, 3, then you have 1, 2, 3, 4, 5, then we have 1, 2, 3. What is happening here is the customer ID is changing. For customer ID 1, we have 1, 2, 3. So this tells us that this is the latest order because it has, we use the descending here. This is the latest order. Then this is the second latest order. Then this is the third latest order. Similarly, as soon as number 2 started, we have 1, 2, 3, 4, 5. Similarly, we have 3, we have 1, 2, 3, we have 4, we have 1, 2, 3, 4. As soon as 5 starts, this changes again. This is how partition by works. Now, how do we use it to our advantage? We know that we want the latest order, which means because we did it at descending order, we need the first sequence for each customer. How we will do it is we will first convert it to a temp table with a as, let's call which it's a temp as. Now I will put it in a parenthesis. This makes it a temporary table. Now I will do select star from temp. Now I will refer to this temp table as my from statement, and I will put a filter where my customer order sequence is actually 1. Now if I run this, you will see that all the or I will get all the orders which have the customer order sequence as 1. So this is all these are all the latest orders for each customer. Now if you compare these two queries, you will actually get the same result. I'll just order it so that you can see. Order by order ID ascending. Order by order ID ascending. So why the data is coming different in both these queries is actually because of a data discrepancy from where I picked the data up. I'll tell you what the discrepancy is. For order number 2401, we have the data as 10th of October, but for order number 2983, which is after 2401, we have the data as 2021, 5th of April. So what actually has happened is that even though the order ID is after the is at a later stage, the order date assigned to this order is actually before. In a real world scenario, this is not possible because when you place an order, the order date will actually be registered as of that date. So if an order was placed today, I will get today's date, and if an order was placed tomorrow, I will get tomorrow's date, and the order ID will actually be incremental. So it would move in sync with the date you have put the order in. In this case, that logic was not formed, which is why this problem occurred. Otherwise, these two statements should have given the same answer. Regardless of that, this was to show you what happens when you do not want to order it basis the order ID, but maybe the order date instead. So if you order it to the order date, you will get this result. And I will put back my where filter, which I removed to check my queries. I'll put it back. And here you go. So now you have all the orders, the latest orders by order date, all the latest orders by order ID. Again, in an ideal scenario, these would give the same result, but in this case, it's giving a different result. Regardless, I will try and fix it before I upload the video. However, I will give you the same data that I have used here so that you get the same results for the queries that we do. Moving on. The next thing which we will look at is categorizing customers based on spends. Now, this is a very important analytical query as well because there will be a lot of times when you have to categorize customers into a lot of segments based on some logics. We'll start off a very basic logic. If the customer is spending more than 500, then it's a medium value customer. If the customer is spending more than 1000 for each order, then they're a high value customer, right? Not for each order, sorry, for the total orders, total spend. Now, this is where we understand the case when statements, or from a normal sense, you will say if else statement, right? Here in SQL, we use case when instead of if else. So let's start it. Select star from orders. Now, what do we need? First thing we need is customer ID. Then we will also put in the total spend. Now we will do the categorization. We'll add a case when. Now I will teach you something very important here, a very logical importance, which is I'll just write the query first and then I'll tell you what happened. When the total price, or sorry, not the total price, the sum of total price is greater than or equal to 500, then we have to assign it as a medium. When the sum is greater than or equal to 1000, we will assign it as high. Else, we will apply, categorize it as low. And we already have the end written here because of the IDE that I'm using, the dbeaver. But and as we write it as customer segment. Let's see what happens. I actually have to write the group by as well. So group by one. Let's see what happens. Right? Now, if you see, all the customers, even with more than 1000 spent, are being categorized as medium. In fact, almost all of them are medium. Right? Why does this happen? This happens because even though we categorize it as high, it should not have come as medium. I'll tell you why. So how the execution works is, as soon as the code enters the when statement, it will check line by line. If the first when statement is successful, or it is successfully, or is it's true, it will consider that this case is now assigned. Sorry, this case is now successful. So what it will do is it will not consider what's written after the first statement. If it gets true in the first statement itself. So because both these statements are true for this amount and 500 is written first, it will say that okay, 500 matches the criteria that I wanted, so I will assign it as medium. It will not even search for the next case. To fix this, we always have to make sure that if we have such situations, we write it in the descending order. So first I'll give the highest, which is 1000. Now I will do 500. Let's see what this does. uh, Sorry, I forgot to change the names. Now let's see what this does. If you see the total spent, wherever it's more than 1000, it gave high, but where it's less than 1000, it gave as medium, which was coming as medium before also, but these were also coming as medium. And now we can see it's high, medium, high, medium. We see medium here somewhere, medium, and I think it's there's hardly any low here. I think there's only one low. I can't see it here. There's only one low here. Now it's categorizing correctly. This is a very important logic for case when that we have to consider the order in which we are writing the when statements. If it's a text-based statement, then it may not make sense. But for a numerical statement where you have this greater than equal to, less than equal to, this is where you have to be very careful. The next thing which we'll see is how to get monthly sales for the company. Right? How many monthly, how many sales were the company doing? This is simpler in that sense, but it uses a window function which is called two characters, and it will convert the date into a certain format. So select from orders, and the first thing is we need the month. So we'll do 2 underscore char, and we will get the order date. We will convert it into a format which we want, which is y. So 4 times y will give me the full year, dash will give me the month as order month, comma, sum of total price as total sales, and I will group it by my order month. If I run this, if you see, I will get all the sales for all the months that I've been operating for. All the data is there for. This is it for advanced queries. There are actually more advanced queries even than this. We will try and cover them later. Although if you want to start practicing on your own, it's better that you go for platforms like LeetCode or HackerRank. These platforms have widely curated SQL questions, and they will help you actually to learn better, to do more tougher questions. I will try to cover some of those LeetCode questions in a live sort of class, or recorded and then put it up, of solving LeetCode questions on video, so that you have more understanding. However, the best way of learning SQL through LeetCode is try and solving them yourselves without looking at the solutions. And you will actually have a lot more. There also, you'll have some categorizations of easy, medium, and hard. You start off with easy, then do one medium the next day, then maybe one hard the next day. You have to proportionate your questions that you pick up very mindfully, and this is the way you can increase your skill set in SQL itself. Now we will look at queries from an analytical point of view, which a lot of analysts may use in their day-to-day life, and especially in an e-commerce company. There are more use cases apart from this. This is just an example and not an exhaustive list. So okay, we'll start with that. We'll first do finding out the cohort of a customer. A lot of times, e-commerce companies divide their customers into cohorts. These cohorts actually define that what life cycle of this customer is this customer in. For example, in this case, we will take that the cohort of a customer is defined by the year and month in which they place their first order. So let's see how we can do that. We need to select start from. Uh, yeah, we'll do it from orders because we need it on the order basis. We'll use something called as to underscore car. This helps you to convert dates into a specific format that you want, a string format maybe. And let's see how we do this. Write order date, and I will define the format in which I want my date. So I'll write y 4 times because I want the full year dash which will give me the month as order month. And here I will use a case when. What I will do is that no, not the case when actually. I will just bring in the the customer ID because here we do not need a case when. Maybe in the next session. And what I'll do is I'll take the min of this because I want the first order basis the date, and I'll group it by one. I have an issue which is a comma. Yeah. So each customer ID is now given an order month, and this order month is the cohort. If I want to see how many customers are there in this cohort, I can just do this instead. I can do a count of customer ID as customer count. I will remove this group by. Oh, actually, I need the group by because I want to group it by the order month. Okay. Uh, Aggregate functions are not allowed in group by, which is true. I think we need to use subquery for this, which we'll do later. So that we can move forward first. I'll just revert it back to customer ID, and we are good to go. We can use it as a subquery, and then we can find out number of customers within each order month, which will give us the number of customers in each cohort, like we did somewhere here, right? Okay. The next thing is customer retention. What do you mean by customer retention? Retention is basically that if a customer places order more than once, then a customer is retained. It's a repeat customer. How do you find that? We need customers which have ordered more than once. So we need to see the order count. What here we'll use a having clause. I'll show you how. So from orders, we need customer IDs, and we need count of order ID as order count, and we'll have to add a group by here. Now we need only customers which have ordered more than once. So we'll add having order count as more than one. Oh, sorry, not the order count. We'll have to write it the same way as we wrote it in the select statement, count. Now, if I run it, I will get all the customers who have placed an order more than once. These are all the customers which are retained on the platform. I can also do an order by the order count so that I can get the customers which are placing the most orders. So we have one customer which is placing 9 orders, which has placed 9 orders with us. Next question which we will look at is a customer lifetime value. This is a very, very important metric which a lot of e-commerce companies track, which tells the e-commerce companies that which customer is providing the highest value to them in their lifetime. So it's called as CLT, customer lifetime value. A customer lifetime value actually covers three things: the total amount this customer has given to us as sales, the average amount this person has given to us, and the number of orders it has given to us. So this is how you do it. You get the first, of course, we use the orders table because this is where our data resides. We get the customer ID. Now we track these three things. Sum of total price will give us the total sales per customer. Average of total price will give us average order value of this customer, and the count of order ID will give us the order count for this customer. These three things give us the customer lifetime value, and we group it by one. Now, if I run it, you get all these three details grouped by customer. So you have, for each customer, you have this value. Now you can sort it according to how you want it, and you can actually see more metrics. You can take decisions basis this data. You can convert these data sets also into cohorts, and you can use it for more marketing purposes. Another similar thing to track analytics is I see something called as RFM, which is the this is also a very important metric from an analytical point of view and from a marketing point of view. This tells you the recency, the frequency, and the monetary aspect. In some ways, it's similar to the customer lifetime value, but RFM model tells you how recently has the customer been active on the platform and or on our website or on the store. How frequently is this customer ordering? And Just a minute. And monetary is how much money this customer has given us. So the frequency and the monetary aspect is actually the same as the order count and the total sales. So we'll skip that. We'll just see the recency. How to calculate the recency here? Star from orders. Now recency is how recently this did this customer place an order. Because we do not have the latest data set here, we'll take the recency from a particular date. I'll consider how recently did the customer order place an order from, let's say, 2022 of 1st January, right? 1st January 2022. I will subtract this date from the order date, right? And the max of order date, because we want the latest order date, and I will put in a bracket as recency, and I will also add the customer ID, and I will group it by 1. Now, if I run it, it will give me all the customers and how many days was the last recent order in. So this tells us that the last order was placed by this customer 32 days before 1st January. And this is the most recent customer, right? If I sort it by recency, it will give me that these customers placed an order 2 days ago. So these are the most active ones. And if we want the frequency and monetary also, I'll just copy this. Sorry, this. Let's put it here, comma. This is the frequency. This is the monetary. Sorry, we have to remove the extra comma and we run it. Now we have the recency, frequency, and monetary. A lot of companies use these metrics to identify the kind of customers they have, and they put them into buckets or cohorts. And these cohorts are then useful for marketing campaigns. The customer which has not been recent, or the customer has not been very active, you may want to try and activate them again by giving them more offers than the customers who have been placing your orders on your platform regularly. That's how some people get more offers than others, and if you might see that some people get more discounts on some things than others because they're not very active on the platform. Just to get those people back on the platform, they give them one-time discounts or more than one-time discounts. There are a lot more things that SQL has to offer. However, this is a very basic understanding of how SQL queries work, how they look, and there are a lot of resources out there which you can read to understand about the window functions better, more deep dive into questions. However, this was more of an overview of what level of queries do analytical roles can expect when they go on to interview or they actually work in the companies. They may be uh, a very high number of statements that you write every day. So this is it for this video, and we will end this video here. In the upcoming videos, you will also learn about Python, how to use Python, how to run Python code, how to integrate your SQL queries with Python, how to generate reports, how to generate maybe visualizations, and a lot more. Right. So we will cover these topics in the upcoming video. Thank you for watching, and please do leave a comment or subscribe if you think my content taught you something new. Thank you.